Hello, and in this video we're going to continue looking at models from data. In our previous video we did linear models. In this video we're going to look at exponential and logistic models from the data. So this is from your worksheet. We're taking the data from the model that how many users were used from Facebook from months after year February 2004, how many users were in millions of this Facebook platform. So they kept records through December 2010 of active users in millions. So let's plot that and take a look at it. Now, in the last video we plotted it and it looked like a line. This one is going to look a little bit different, so we're not going to use a line of best fit in this because it's not going to look like it's going to be linear. So when you graph these, you want to take a look at what they look like in order to decide what kind of model you're going to use. So here again we're going to start with stat. Now I cleared out everything from the last one. So we're going to start with edit. Actually, the last one's still in there. So let's practice clearing it out. So we go up to L1, push clear, and enter. That clears out all the data in L1, but it's still there. It's not deleting it. We're not using delete. We're using clear and enter to clear the data so that we don't have to go and push delete on every single data point. So let's put in the data 10. 22, 34, 44, 54, 62, 67, 72, and 77, and 82. And the last one they put in, that was December 2010. We're going to go over here and put in how many active users we had in millions. 1 for the first one, 5.5 for the second one, 12 for the third one, 50 for the next one, 100, 200, 300, 400, 500, and 608. Alright, and they should line up here, so if they're matching, we have a good chance we entered in the data correctly. Now we're going to have to reset our window. Now this window has been reset to standard viewing rectangle here. We started out at 10 and we went to 82, so we're going to need to be at least, I'm going to put -5 in there so we can be a little lower than 10. And 82, so we're going to go up to 100 in this case. We're going to go by 5s. And then on these we have 1 to 608, so we're going to go -5 here also. And to 608, so we're going to go maybe a little bit higher, 700. We'll go by 50s there. Let's go by 10s up here. Okay. So we have our windows set. We need to make sure our stat plot is turned on. So we hit second stat plot, or y equals. So we are all off, so we got to go and hit enter on the first one. This is plot 1. Let's make sure it's on. It's set properly to data points. L1 and L2 are chosen. We should now be able to graph. Alright, as you see here, the data doesn't look like it's a straight line. It doesn't go from here straight up. It curves. It's growing. So we're going to use the exponential model on this because it kind of looks like an exponential model. If you remember when we graphed the exponential models, they kind of curved in this manner. So we're going to use an exponential model on this. Alright, so we're going to plug that in there. That would be under stat calculate. We're not going to use linear, so we'll go past that one. We keep looking. We don't think it's a quadratic or a cubic or a fourth power It's still not linear. It's not a logarithm because it doesn't turn that way. We think it's exponential. So we're going to put that one in there, exponential. Enter twice, and it gives us a formula for exponential. Here it is. It tells us the A value, which is the initial value, and how much it's growing by. It looks like it's growing around 9% a year. So our equation would be A or Y equals, we can see it right here, Y equals A times B to the X. We have the A value there, which is 0.656 rounded to 3 decimal places, times 1.093 rounded to 3 decimal places to the X power. So that's our function of best fit. Now we're going to look at that and see if it fits pretty good. We're going to type it in there, Y equals 0.656 times 1.093 to the X power. And we're going to graph that alongside with this one so we can see how close a fit it is. It looks like it's a little bit, it doesn't fit exactly well, but it does look pretty close. It would be better than a line because it does hit these data points or closer to those. Okay, so we found the exponential model. It's a recent fit. We're going to go the monthly rate here. I was mentioning that here. It looks like that is 0.093 or 9.3% is your monthly growth rate. And we know it's monthly because that's what it's set up here in our chart, monthly. So that was our time increment. All right, now if we wanted to, the better these fit this data, the better the model here. We're a little off on this one, so there may be a better model, and in this case we're going to test out that model, which is called a logistic model. Now it's saying here no quantity, in the long run, no quantity can continue to grow exponentially as there's some limit will be reached. With populations, these limits may be resources. In this case up here, it may be we just have that many users. There's going to be a limit on users because not everybody's going to continue to use that Facebook thing. So this is going to be our equation model, and we can look at it as an S-shaped curve. So it's going to look like this when we graph it. It's going to go like that. Whereas an exponential model goes like this, upward, and it increases. So that's what we're going to do here. We're going to make this model change to a logistic model. All right, so we're going to find the model logistically and write it down. Okay, so that's under Stat again. Calculate. We got to go down until we find the logistic model. There it is. It's letter B, logistic. Push Enter twice. And we're going to write down this model as the calculator finds it. And we will take a look at its graph and see if it's a closer fit than the one we had. Now this usually takes a little longer on the calculator to compute. And on 83 it takes longer than the 84. 84 has more memory. It's still thinking about it because it's scrolling up here. Alright, it's found it for us. It gave us all the values, C, A, and negative B here. So there they are, A, B, and C. So I'm going to write those in the equation, which what I see here, Y equals, C goes on top, so it's 865.64, 865.64 over 1 plus A is 160 or 1681, 0.53 e to the negative, and b here they have 0.101. We'll go 4 decimal places there because it's the exponent. Just to give us a little more accuracy, 009 x. So that's going to be our denominator here. Okay, and that's what we found in here for that. Now let's graph that and see how close a function it is. Alright, so we're going to take that and put it into our y equals. I'm not going to get rid of this one. I'm just going to push enter here so that it doesn't graph that. And we're going to type in this other graph, which is 865.64 divided by parentheses 1 plus 1681.53 second e to the x, and that's going to be negative 0.10089, and then x power, and the parentheses on the EVX and the parentheses on our denominator. Alright, and we're going to push graph here. We turn off this graph, it shouldn't show it anymore. We'll push graph and see how close a fit this one is. It looks like it's a closer fit, and we're turning here, meaning we have a limiting factor. If we looked at our window being higher, let's see, 700, let's go a little higher so we can see the limiting factor. Let's go to 1,000, and we'll go to by 100 here. Graph. You can see it turning there and it getting to a limit. So there's a limiting factor. We need to go a little bit to the right more. Let's go 150 here. Graph. And you can see that there's a limiting factor and it gets close to that factor there. Now you can see the limiting factor. Okay, now the upper capacity, or the upper thing here, is called the carrying capacity. Now that's the top number up here, so that's where our asymptote's going to happen here. And according to this, that's going to be 865.64. Is it million or billions of users up here? Millions of users. So using this model, it's saying that we're going to approach this value. The largest amount of Facebook users are going to be 865.64 millions of people. So that's our carrying capacity that's based upon this number right here. And this is a pretty good model. You can see that it fits a little bit better than the exponential. And it makes better sense if there's a limiting factor. So that's logistics graphs and exponential graphs. That's concluding that part of the video on other types of models for data. So we have 3 model types that we've used. There are more found on the calculator. You can look under the stat menu and look under these as all the different models you could use.